This lesson, we're going to talk about exponential function. Standard form of exponential function look like this, where b is base, x unknown is going to be on the power exponent. When this is going to be standard shape of exponential, if the b is positive, if b is between 0 and 1, this is going to be the standard shape, where you will see that it goes through y-intercept 1, and your domain is going to be negative infinity to positive infinity, and range is going to be 0 and up. It will never touch 0 x-axis, but it will go close to. And we can see all that information from the example better. We're also going to go over interest formula. This is going to be simple interest formula. This is compound interest formula. This is the continuous compound interest formulas. So the reason we're bringing these two formula is because if you wanted to find out the times or rates, depends on which formulas that are known, it's going to be on the exponent. So that's dealing with exponential. So let's look at the first example. Is asking to graph this exponential functions. And one way of doing it is by plotting the points. So when we plug in the point, you have x and y. When x is negative 1, this is going to be 2 to the negative first exponent, which is 1 over 2. When x is 0, it will be 0 exponent will be 1. When x is 1, it will be 2 to the first exponent is 2. When x is 2, that's going to be 2 squared, which is 4. So some of this information you have when x is 0, y is 1. When x is negative 1, 1/2. When x is 1, it will be 2. When x is 2, it will be 4. So that's the graph you're going to have for this exponential. And like I mentioned, your exponential basic shape look like this or that, right? And on top of that, once you understand the basic information like passing 0 and 1 for y-intercept, and you have horizontal asymptote, y equals to 0, right? This is horizontal asymptote. So if you have some of this information and understanding a little bit about exponential, you should be able to graph this second functions by transformations. So same base, 2 and 2. Only thing different is you have minus 1 to the variable x. So minus 1 to the variable x will give you shifting right 1 plus 2. So add or subtraction to the whole function itself is going to be going up and down. Because it's positive 2, this is going to be going up 2. So like I said, you should be able to plug in points like this to find this graph, but also you should be able to use transformations. So that's based on this point right here. I'm going to transform this y-intercept to move up 2 and right 1, right? Move up 2, right 1. So from 1, move up 2, right 1 will be this point. And your horizontal asymptote, if you do from y equals to 0, move up 2 and right 1 will be y will never be equals to 2. That will be your horizontal asymptote on that problem. So your graph should look like exactly same shape, but going up to move right 1 unit. And I wanted to show you when your base is 1 over 2 also. If your base is 1 over 2, let's see what happened by plugging the points. Let's do maybe 3 points. When x is negative 1 is 2. When x is 0, when x is 1, and when you plug in that 3 points, it will be passing 1. 1 will be half, and negative 1 will be 2. So it will be look like that. And it will have same horizontal asymptote. So y can never be equals to 0 or under, right? This kind show you basic graph that I was talking about, right? When base is greater than 1, your basic shape look like that. When base is between 0 and 1, it will be this directions. And this example proves that's right. What about if your base is e, right? Again, you should be able to get, let me do blue. Example or graph by plotting the points. E to the negative first exponent, it will be 1 over e. When you plug in that value into the calculator, it gives you 0.37. Any numbers to 0 exponent is 1. Any numbers to the 1 first exponent is that number itself. And Euler's number is 2.72, right? So it will be look like passing y-intercept 1. When it was negative 1, somewhere right there. Positive 1 will be 2 point something, close to 3. Which also have horizontal asymptote y equals to 0. This graph should be giving you the basic information about exponential function. Example 3, we're going to go over very basic exponential solving. So if we have 3 to the x plus 1 exponent equals to 81, we wanted to find out what x is going to be, right? So what we can do is trying to make a same base. If we make a same base, then we can drop the base and see what do I need to do to make it same exponents, right? So this is going to be just stay as it is. But we know that 81, I can rewrite it into 3 to the 4th exponent. Again, long as you have a same base, we don't have to worry about base. And the only thing that I'm worrying about, in order to make this equal, how do I make x plus 1 equals to 4, right? So because if that's equals to, then it will be equals to each other. The whole thing will be equals to each other. So then this is going to be subtracting both sides by 1. You end up getting 3. So your x should be 3. So if you wanted to check that, you can check by plugging those values into the beginning problem. Not in the middle. Do not check it here because what about if you made a mistake, right? So always check your solution from what you started. So when you do that, it will be 3 to the 3 plus first exponent should be 81. Let's see if that's true. That's 3 to the 4th exponent. 3 to the 4th exponent is 81. Yep, checks out. So we know that x should be equals to 3. What about the next one? This time you have both side exponents, variable. Exponent with the variable, unknown variable. But still we're going to trying to do same thing. So long as we can make the same base, we can drop and don't think about the base. We can only set the new the exponent equals to each other and solve that exponents, right? So look like I know that this 8, I can make it into 4. Well, 2 to the 3rd power. This 4, I can make it into 2 square. And that's going to have the same base of 2. So 4 become 2 square. And 8 become 2 cube. So this way you will have same base. If you wanted to simplify your exponent because you have double exponents, you just need to use the rule of exponents, which is double exponent means multiplications. So it will be 2 times 2x, 2 times negative 1. The other side, same thing, you're going to distribute 3, so it will be 3x. And 3 times 3, 9. So long as you have same base, 2 and 2. If I can make this equals to this, the whole thing will be equals to each other. So we drop the base, let exponent equals to each other. And solve for x. So I will do subtracting 3x to put number with the variable on the left side. And I will add 2 to put number without the variable on the right side. So I will have x equals to 11. Again, one good thing about solving equations, you can always check your solutions to make sure, right? And when you check, you should be always plug in where you started. So it will be 4. 2 to the 11th exponent minus 1 should be same as 8 to the 11 plus 3 exponents. 4 to the 22 minus 1 is 21. Power should be same as 8 to the 14 exponents. And you should be able to check that using your calculator. Let's look at the next example. What about this? C. First thing I wanted to do is get rid of maybe this fractions, right? Where's the fraction? This fractions. So in order to get rid of that fractions, I will rewrite the exponents And maybe open the parentheses, so it will be 2 times x is 2x, right? And this becomes e to the negative third power. And after I get rid of fractions, look like I have multiplications with the same base, so maybe I can combine this, right? Same base, different exponents, so that's same as adding, right? So it will be 2x plus negative 3, which is going to be 2x minus 3. Now you have same base on denominator, so you don't need to worry about if I can make this exponent and this exponent equals 2. The whole thing will become same, right? So once you have same base, drop the base, let the exponents equals to each other in order to solve the variable. Look like I will have quadratic equations, right? Quadratic. So as soon as you realize you're dealing with quadratic, the highest exponent square, you want it to make a standard form and leading coefficient positive. So I'm going to move this one term into the other side. That will give you positive x squared plus 2x minus 3 equals to 0 is same as equals to 0 on the other side, right? And this is factorable. It will be x plus 3, x minus 1 equals to 0, where you get x equals to negative 3 and positive 1. So example 4, we wanted to trying to understand the interest formulas, right? Once we understand the interest formula, then we should be able to use that interest formulas to find the exponents later on chapter. And this problem, it says suppose that 5,000 is invested at 6.5% interest, right? Following compounding options. You have one with annually, compounding quarterly, and compounding continuously. So here is the formula that you need to remember from the page before. This two, compounding interest formula, you're going to use amount is equals to principal times 1 plus rate over n to the nt exponents. So P is stand for principal, how much you're going to invest. R is going to be rate. N is going to be compounding period. T is time. Here, N is again compounding period. Okay, so you're going to use that formula for that first two. The compounding continuous interest formula is amount is equals to principal time e to the RT exponents. Again, P is principal, E is Euler's value, R rate, T time. So if we wanted to start with the first one, compound annually. Compound annual means once a year. So your n become 1. And when we plug in that to find your amount, your principal is 5,000. 1 plus your rate is 6.5%. You need to change that to decimal, which will be 0.065 over compounding period n equal 1 to the 1 and per year. So your time is going to be 1. If you simplify this, it will be just pretty much 5,000 times 1 plus 0.065, which will give you 1.065 to the first exponent. So when you multiply that together, you will end up getting 5,325. So that will be the total amount. Total amount means principal time interest. Since principal is 5,000, your interest is going to be 325. But they are asking you to find the amounts. So that's your amount. Total amount for A. And B, they say find the compound quarterly. Quarterly means 4 times a year. So your N is going to be 4. Let's replace that number. 5,001 plus 0.065 divided by 4 times 1. So that gives you 5,000 times 0.065 divided by 4 is 0.01625. Plus 1 will be 1.01625 to the fourth exponent. When you place those values to the calculator, you get 5,333.01. So when you're compounding quarterly, will give you a little more than when you compound yearly, right? That's the comparison between yearly versus quarterly. So you're compounding 4 times a year instead of 1, right? Let's look at the C. It's asking compounding continuously. So when you plug in that into the given formula, it will be P, principal, times E to the R, rate, times T, which is 1. This will give you, because E is the Euler's value, 2.71828 ... right? When you do have this value on your calculator if you wanted to use. Otherwise, maybe you can use 2.72 as the round number, right? If you don't have E on your calculator, use 2.72 maybe, right? Times 5 to the 0.065 exponents and equal, and then multiply that by 5,000, you will get 5,335.80. So comparing all three solutions, look like compounding continuously will give you a little more money than the other two options.